Welcome to my channel. Today I'm going to discuss the distance of the sun away from the earth. And this is a sticking point with a lot of people who accept the flat earth model. They feel that the sun is much closer and much smaller than most scientists would accept. I won't discuss the size of the sun today, but I am going to get into the distance of the sun. And the way we're going to calculate the distance is by using the planet Venus. The nice thing about Venus is it is an inert body, so we can actually bounce radar waves off of the planet Venus and actually measure directly the distance of Venus at any point along the way in its orbit, as long as it's not on the other side of the sun, of course. But the distance taken at a particular point will be critical to our calculation, in that we're going to look at Venus when it is the farthest distance from the sun relative to Earth. So we have an angle of elongation, they call it. That's the distance from, or the angle from, the sun relative to the Earth looking at Venus. So that distance only gets to be a small amount because of the simple reason it's Venus is so close to the sun, and it tends to rise and fall at the horizon about the same time the sun does. It stays up. It either comes up before the sun in the sunrise, sometimes we'll call it the morning star then, or it will set after the sun, and then we'll call it the evening star. But the fact is, in either case, it's following very close to the sun, and it will go down. You won't find it up in the middle of the night. The point where it is the farthest from the sun is going to be shown in a triangle I'll be working with shortly. But what we need to know is, when it is the farthest distance from the sun, how far away is Venus from us, from Earth? The way we figure this out is using radar. Radar, something I work with in the Navy. Radar is very effective in measuring distances precisely. We can send out a powerful burst of RF energy, electromagnetic energy, and it goes out through space, hits something, and bounces back. And we can time the travel that signal makes. And the time it takes to get there and come back is indicative of the distance that it is away from us. Of course, it's going to take twice as long for the echo. So it's actually going to tell us double the distance of whatever it is. But we use this for tracking airplanes or anything else. We care about the position, boats on the ocean. In this case, we're going to track a planet. And they have found that when Venus is at this point where it's at greatest elongation, by bouncing the radar off of Venus, it has been established that it's 66.96 million miles away from us. And we figured this out using this formula here. Rate times time equals distance. The speed of light, of course, is the rate, and the amount of time is what we measured. As it turned out, it took 720 seconds for the signal to travel from Earth to Venus and back again. And by multiplying that times the speed of light, 186,000 miles per second, you come up with 133.96 million miles. Divide that by 2, you end up with your 6696 of Venus. So now we have one leg, the adjacent leg of this angle at Earth. So between Venus and Earth, the distance was known. Now we need to know what the angle is. We measure that, and that came out as 43.95 degrees at that instant in time. So we know the angle, and we know the adjacent side. From that, we can calculate the hypotenuse of this triangle, which is 1 AU, or the distance from the Earth to the Sun, and vice versa. We'll do that using this formula here. We have the hypotenuse is going to equal the length of the adjacent side divided by the cosine of the angle theta. Well, we know that the adjacent side is 66.96 million miles. We know the cosine of theta of 43.95, and from that we divide them together and we'll come up with 93 million miles, which gives us 1 AU. That's the 1 astronomical unit, the distance from the Earth to the Sun. That's approximate numbers, but that is definitely very close to the right value. So there's absolutely no way it could be way closer than that. It would have to be out past 90 million miles at least. And so this is one way we can scientifically prove the distance from the Earth to the Sun. I hope you'll find that helpful, and I'll see you next time.